Let's not overlook some of the basics just because we're in an advanced class. For example, how about the quantity of fuel? How long should the injector be kept open by the PCM? Well, in PFI we base that on inputs, and in GDI we're going to base that off the following inputs. The fuel rail pressure sensor tells the computer, it reports to the computer what is the pressure inside the common rail at any given moment. So the computer can use the pressure to calculate how long the injector should be open. The boost pressure. If this engine has a turbocharger on it, then the pressure inside the intake manifold is going to be greater than atmospheric pressure, and that means more air is going to enter the cylinder, and the computer has to match that with the fuel. Coolant temperature sensors have been around a long time, and most of us are familiar with them. In the old days we used to say this was the choke of the system. Whether that still stands or not, I don't know, but cooler engines require additional fuel, and as the engine warms up and the coolant temperature changes, the computer has to adjust the injector on time. How about the charge air temperature sensor? Well, if, once again, it has a turbocharger, the charge air temperature sensor is going to be an input. And then the inlet air pressure, that's going to tell the computer how much air is entering the engine if equipped with a turbocharger. How about those accelerator pedal position sensors? How much load is the driver requesting from the computer? And then engine speed. The computer has to know the engine speed. Now, whether we have a fuel rail pressure or a boost pressure sensor, all pressure sensors work the same way. They're 3-wire sensors. The coolant temperature sensors are a 2-wire, just like the charge air temperature or the inlet air temperature or the transmission oil temperature sensor. They're all the same. And the pedal position sensors are just like the TPS. They're potentiometers. They report to the computer the position of a component. Engine speed is everything. We know that comes from the crankshaft position sensor. For example, the load inputs are used to determine exactly how much fuel should be injected. That would be the injection on time. These load sensors report to the computer how much the driver's requesting. Are we going up a hill? Are we pulling a trailer? Engine RPM and camshaft position inputs determine when the fuel should be injected. Exactly when and how fast the injection on time needs to be. When the engine RPM increases, the computer has to make more injections per minute. And where is that camshaft position sensor reporting? It's reporting when the valves are in the right position for injection. Most inputs are easily checked with a scan tool. Now that's a big statement. You're sitting in the front seat of the car, you have the scan tool in your hand, and you can go to OBD2 Diagnostic Test Mode 1, or what we call PIDs. And these PIDs will report any electrical faults. How do they do that? Inputs that are shorted or open are going to be way out of range. They're going to be too high or too low in the voltage. Now that's important because remember the basic electrical. It is powers, or B+, that brings voltage up. It is grounds that bring voltage down. So if the inputs are too high, go check the grounds. If the inputs are too low, go check power. These have a certain amount of range in electrical signal that the computer will represent as good or bad. If they exceed that range, what's going to happen is the computer's going to set a diagnostic trouble code. Now, when we get a code for an input, it doesn't mean replace the input. It means checks its power and its ground, and of course, its calibration. Now, the calibration of a sensor can be tested by comparing the sensor value to a known good specification, or in the case of a temperature sensor and the engine hasn't been run for 6 to 8 hours, then they should all read the same thing. Key on, engine off, all the pressure sensors should read the same thing. For example, atmospheric pressure. So don't forget to test the calibration of sensors with the key on, engine off, and then of course at idle. city speeds somewhere around 35 miles an hour, and highway speeds somewhere around 55 miles an hour. Testing computer inputs haven't changed just because we're with a GDI injection system.